Hey y'all, welcome. Yeah, so first, as always, thank you, Lord Christ. I love you so much, God. Thank you for everything, and be with everyone who loves you. And as I'm sure you'll be, you don't need my reminders. And yeah, so in the previous video, I talked about the difference between discrete random variable and a continuous random variable. And I said a little bit more. So watching that video will be of great help, of immense help to your understanding of this video, right? It's a really good segue. And so if you find yourself like struggling to understand a little part of this video, then you ought to go back and check out that video. Okay, cool. So what is this giant formula? Apparently, like, they use it in finance, so it's good to know that finance is anchored in statistics and probability, which is like math. But yeah, what it is it's a measure of skewness. And so in the previous video, as I said, the video I mentioned, I name dropped skewness, right? And skewness is like the description of how a particular random variable is distributed, right? And very counterintuitively, this would be considered right skewed, because I would think this is right skewed, but this is right skewed, and this is left skewed. So right skewed and left skewed. Yes. Okay. I quit in the middle of spelling skew. I think I got it right the first time. Okay, anyway. So like having watched the previous video or having come with your own understanding, I can say that clearly both are a continuous random variable, and let's say that they both describe height of people, and let's say this is Mexico. So the Mexican height, this is why I'm the tallest Mexican. And this is, let's say, like, I don't know, Sudan. Like when I think of like tall people, I think of Sudan. So that's like height of people in Sudan, and this is height of people in Mexico, right? Okay, cool. And so this is supposed to spit out a number for a particular random variable, and it's supposed to be a sample random variable for a sample distribution. Sorry. I'm stuttering. No, it's supposed to be for not the population, but for a sample random variable. And so like, let's keep it this way and like help us. Jesus Christ, I can't talk today. Let's keep it this way, and that way, like, you know, it's just about understanding this formula, right? Okay. So, first, like, n is the sample size, right? So if you sampled like 100 people, n would be 100, and otherwise, this s is the sample standard deviation. This xi is like any one of the statistics in the random variable, so like a specific height, right, and the sample, that would be like xi, and of course another xi, like x1 may be a specific height, and x2 is a different height, and blah blah blah, right? And so x in general here is like height in our example, right? And x bar, obviously you should know, is the mean, right, or the average. And this is all cubed. Now, I never ever like to talk about things I don't fully understand, but like I was so eager to share this, and it's been in my head for a while, sharing this as soon as I got on the board, right? And so I want to share it, and if anyone knows more, I would be more than happy to, like, you know, hear your breakdown of this formula, but I still nonetheless found it valuable to share, and so yeah, so I'm gonna explain to the extent that I understand it, or like at least the main parts that I understand, right? Okay, so on something like this, versus something like this, where would the mean or x bar go? So here, like I would say the mean or x bar would go, because the mean is the average, right? It would go somewhere like here, right? So let's say x bar is here, right? Okay. So then, for right skewness, by the way, the number spit out by this formula is unitless. So you're just saying, is it 0, is it negative, or is it positive? That's all we're looking for. So like if x bar is right here, then like these are a bunch of x's, right? So like let's say that a height of like 4 feet is like here. So this is 4 feet and 5 feet, and that's really like saying the Mexicans are tall and stuff, which is not true. But let's just go with it. And so like 6 feet is there, 7 feet, 8 feet. Let's just say that this is the height of giraffes in Mexico. They're probably like the same proportional to like people or something. I don't know. Okay. I get less and less offensive by the minute. Okay. And so similarly, this is like 4 feet right here. So the Sudanese giraffes are really tall, and 5 feet. And this time, like the average or the mean would be like, you know, if we kind of use the same kind of estimation, it would be like somewhere about here, right? Okay. Now notice that this is cubed. So, like if the mean I'm saying in this case is 6 feet, right? And so here, 6 feet, 7 feet is the mean in this case. Whereas here, x bar is 7 feet, right? What would happen to this quantity in the numerator? Right? First, remember the standard deviation is the square root, so it's a positive quantity. S is a positive quantity. So like, and remember, a cube spits out the same parity as the number you put in, which is to say, like, if you put in, if this is a negative number, when we cube it, we get a negative number. And if it's a positive number, when we cube it, we get a positive number, right? Okay, so what's the nature of xi? Each of the heights minus the mean. Well, if we use this example, because I don't like the number 6 repeating, whereas I love 7 repeating. So we use the Sudanese example, right? Like, we're saying that, like, well, like there are, like, the smaller quantities are to the left of 7 feet, and they're farther away, right? And since, like, there's going to be, like, an equal amount of area here and here, right? Like, when we do each x, like 4 feet, 4 minus 7, and of course, like, there aren't just 1, 2, 3, 4, 5 people. It's going to be more than this, right? 4 minus 7 cubed. I'm only looking at the numerator quantity here. Plus 5 minus 7 cubed, blah, blah, blah. And then we're going to what? 7 minus 7 cubed. And then we go to, like, 8 minus 7 cubed, 9 minus 7 cubed, and so on, right? Okay. These numbers are going to be closer to the mean, right? Like, these are going, because it's skewed to the left. So, like, these parts are going to be closer to the mean. So when we subtract and cube and these parts to the right of the mean, we're going to get positive numbers, but they're going to be small positive numbers. Whereas, like, there'll be, like, this, because of the area situation, there'll be, like, as many numbers on the left of the mean in these parts, but they're farther away from the mean. So when we cube them, we're going to get bigger negative numbers. So we have smaller positive numbers in this part. We have bigger negative numbers in this part. When we add them all together, because that's what sigma has to do, and again, because s is always positive, it's not going to affect the positiveness or negativeness of this quantity. Only like this versus that will, right? Like, as I said, in this situation, we'll get like bigger weights of negative numbers in these parts. So the aggregate, this sum, is going to come out to be a negative. And of course, the sample size is positive. So this is a positive quotient right here. So we have positive and then a negative number out of this multiplied. So we're going to get a negative number, right? So this is negative and sx, right? Sx in this is going to be negative. So then that explains why left skewedness is also called negatively skewed. You can do the same kind of analysis to figure out that right skewedness would then make this quantity positive, right? Whereas if your discrete random variable is symmetric, that's to say normally distributed, right? And there are a lot of things that are normally distributed. Like if we take like height of like every population where the geography doesn't affect it, I believe that's normally distributed. There are some short people, there are some tall people, the rest are in the middle, right? So a perfect bell-shaped curve is a normally distributed curve. Then this would give you a 0 value. So it will be close to 0. So now I did say that, like, you know, I would see. I feel I have at this point sufficiently explained it, but like I did say that, like, if there's anyone who wants to add to it, I'd be happy to listen, and as I'm sure everyone who's watching would also. And so what I want like additional input on is like, why is S there? What's the point of S here, the standard deviation, and why is this quantity there? Like and spitting out this number. All I could really understand here is like on this part is that like it would give you like a smaller positive or negative number, and so since your purpose is understanding like negativeness versus positiveness, it doesn't matter. It'll still give you like, you know, it'll still give you the sense of what you're trying to get, because this denominator is bigger than the numerator, obviously, right? And but otherwise, you know, I don't really see why like whoever derived this formula like decided to put that quantity there, and also why is S there? So if anyone wants to like thoroughly explain these things, yeah, you have an ear. What? No. okay, all right. And also like a nice little pleasant thing that I found is like I don't really look at the statistics of my channel. Like ain't nobody got time for that. But like yeah, I on occasion do, and I like learned that there are like a good portion of people like over the age of like 50 who like watch this channel. And I don't know if you come because of my love for Christ or you come for the math, but whatever the reason, like you're very, very welcome. And like I'm humbled that there are people like who are interested in listening to me and aren't just 15 years old. Yeah, okay. All right. Have a wonderful day. And yeah, okay. Take care.